let's try to solve another Leetcode problem. 2197. Replace non-coprime numbers in array. And let's first try to understand what is non-coprime. So the coprime is for numbers like 2 and 3. This is a coprime because 2 is a prime number and 3 is also a prime number. So this is a coprime. So for numbers 2 and 4, so this is a non-coprime. So this means they have a GCD of those two numbers. It's gonna be 2. Yeah, if the GCD of the two numbers equal to 1, so it means they are coprime. If it is not, it means they are non-coprime. And you can also say the descriptions from here, because so here is the description about it. And normally we're gonna use this kind of a property to solve the problem. Yeah. Now let's just check the conditions. So we're going to find any two adjacent numbers in nums that are non-coprime. So any two adjacent numbers. It is not any number. It is not any two number. It is not any adjacent number. It is any two adjacent numbers in nums. Yeah, we have to use this property. If you forget about it, definitely you cannot solve it. Yeah. So it is any two adjacent numbers. It means these numbers are like 4 and 6, like 4 and 6 and 4, 4 and 3, 3 and 2, 2 and 7, and it must be adjacent, and it is only two numbers. Yeah. So we're gonna check all those numbers. So if we use brute force, normally it's gonna be n squared. So this is 10 to the power of 5. It means we cannot pass it. Yeah, definitely we're gonna use some data structure to solve the problem. And stack is an optimal way to solve this problem, because stack can be used to check the two neighbor elements. Yeah, because if you put a number, so for example, if you were to put a number inside the stack, so this is our stack. If you were to put a number inside the stack, this is the 6, and it is okay. And now you were to put a number 4 inside of the stack, so because of the GCD of 4 and 6, more than 1, because GCD equal to 2. If it is more than 1, we're gonna do some operations. So firstly, we're gonna pop out, we're gonna check those two numbers. Yes, this is 4 and this is 6, but we're gonna pop out one number. So we're gonna pop out this 4, and we're gonna update it to the least common multiples. So it's gonna be, I forget it. So what about how to update it? So if no such numbers are found, stop the process. If we didn't find it, we're gonna stop it. Yeah, it is okay. So otherwise, we're gonna delete the two numbers and replace with the least common multiple. Yeah, it is the least common multiple. So for example, we're gonna delete it and replace with the least common multiple for 4 and 6. What is that? So it is a 12. So currently, we just have a 12. Now we're gonna continue. So now we have number 3. So what about this 3 and 12? So 3 gonna compare with 12. So the GCD gonna be 3, and now we're gonna replace it. And this 12 gonna be updated to 12 because least common multiple is still 12. Yeah. Now we are okay. We're gonna continue. Yeah. We're gonna continue to check the next number. So it's gonna be 2. 2 gonna still be the 12. And next we're gonna put 7 inside, because GCD of 7 and 12 it is 1. So it is okay. We're gonna put it inside. And next we're gonna put 6 inside, because 6 and 7 they are two neighbors. The GCD is 1, so we're gonna stop the process for this loop. Now we're gonna check the next. It is number 2. So for this number 2 and 6, we're gonna compare directly, because GCD equal to 2, it means more than 1. So we're gonna update this 2 with this 6 to 2, because LCM of 2 and 6 it is 6. Yeah. So this is gonna be the final answer. So it's gonna be 12, 7, and 6. Yeah, we just need to simulate it like a stack. So this means, so for some of the problem, if it is two neighbors, we're gonna always check two neighbors, so stack can be used, and this is gonna be just be optimized to like O1 solution, because this is why we're gonna use a stack. Yeah. Now let's just try to use it. But the time complexity maybe we're gonna analyze as n log n, because inside we're gonna calculate the GCD or LCM. Basically, that will take log n time. Yeah. So as I said before, I'm gonna simulate it like a stack. Now I'm gonna check all the numbers inside of the nums. So for n in nums, first of all, I'm going to put it inside of the stack. So if the length of the stack is more than 2, this means at least I have 2 numbers I can do some operations. Yeah. So if the length of the stack is more than 2, this means at least I have 2 numbers inside of the stack. For example, I have numbers 6 and 4 inside of the stack. So this means I can do some operations. But before that, I'm going to check it as a result. So I'm going to set it to be a G. G means the GCD result. So basically, it's going to be GCD with 2 numbers. So I'm going to set the 2 numbers as n1 and n2. Basically, this is going to be equal to stack -1 and stack -2. I will not do any operation about the stack yet. I'll just take the 2 values at the end of the stack. So if I take 2 values, I'm going to compare with them. Just use GCD of n1 and n2. Now I'm going to check the result of this G. So if the result G equal to let's say if it is equal to 1, so basically we're gonna stop the loop. But this means we're gonna stop it here. We're gonna not stop the for loop, otherwise we cannot get the result. This means from here we cannot use if, we have to use a while check. So while the stack is more than 2, we're gonna always do this kind of operation. Yeah. So if it is equal to 1, so we're gonna stop it. So for example, from the beginning, so for the numbers like 5 and 3, from the beginning, it is okay because GCD of 5 and 3, it is 1, so we're gonna break it. And after break it, we're gonna continue to check. We're gonna put the next number inside, maybe 6. Yeah. So for this 3 and 6, of course, GCD gonna be 3 more than 1. We're gonna do some operations. So this is okay. So otherwise, we're gonna do some operations. So we're gonna take out a value. Yeah, because this is basically the operations from here. We're gonna delete 2 numbers and replace them with LCM. Yeah. So let's just take out 1 number. So x should be stack.pop. We're gonna pop a number at the top of the stack. So we're gonna pop it out. But after pop it out, we're gonna update the value. So after pop out, we're gonna update the value with stack -1. Yeah, because in this position we're gonna update the value, and from here we're gonna update with the LCM. So how to calculate the LCM? So we can use different ways. We can, let's just try to use a normal way. So the normal way gonna be LCM with this x and stack -1. Let's just have a check. So this x, we just pop out a number, and this is just another number, and we're gonna put it in at the head of the stack, on top of the stack. We're gonna put it on top of the stack. Yeah. Now I think that's all about it. We just need to return this stack. Yeah. Or maybe you're gonna use GCD. It is still the same. Yeah. Let me just make a comment from here. Maybe you don't want to use LCM. Let's try to use GCD. Yeah. So the GCD gonna be stack -1. Times this value x, but we need to divide it by this G. Yeah, so this is the formula of LCM, or you can use LCM directly. Now let's just try to check if it works. I did something wrong. Let me check. So from here, for this is 6 and 4, while it should be more than 1, it is not more than 2. It's a stack more than 1, so we're gonna do such operations. Yeah, it is not 2. Now, as you can see, it should be okay. Yeah, we have to be careful about it. If the length is 2, I mean the stack, the length is 2, so definitely we're gonna do the operations. Yeah. Now let me just submit it to check if it works. As you can see, it works and it's pretty fast. Yeah, because from here, basically for these areas, the time complexity is O(n). Even we use the while loop, but this is a stack operation, and it is just O(n). And for here, we're gonna use a GCD. We're gonna say it as log n time, but basically it is okay. It is much faster even than log n time. Now we're gonna check here. Maybe we don't want to use GCD, so let's try to use LCM because it's the same idea. Yeah, as you can see, LCM also works. We can use LCM directly as well. Yeah, this is just according to the question. We're gonna use LCM. Yeah. So I think that's for today's question. Thank you for watching. See you next time.